So Bernie and I were just wandering around ASFM and we wanted to know how tall is that building you can see right there. And obviously we cannot measure it directly, but there's two ways we did it. We did it with a shadow method and the mirror method. The first method you will see is the mirror method, and how this works is basically you put a mirror and you try to see the top of the building and then you measure. I will get more into detail, but I just wanted to let you know that when you measure it, there's two triangles and they're similar because the sun creates a shadow, and since we're in the same time of day, the shadow will be equivalent for both triangles, and therefore we have one side that is the side we measure and the shadow. And if we know the triangles have the same ratio for both sides that we measured, then we know that those triangles are going to be similar. Keep in mind that I'm talking over the video because in the video the audio was messed up because there was a lot of wind. Alright, so we're doing the mirror method, and first I needed to step back, and the iPhone you can see right there is a mirror, and I needed to see the top of the building. And now Bernie's measuring me to measure my height, but keep in mind that the height in the mirror method is measured by my eyes, because when I'm looking at the mirror, I'm not looking it from the top of my head, I'm looking from my eyes, obviously. So the measurement we got here was 167. So from my feet to my eyes, it was 167 centimeters. And now we're measuring the distance between where I was standing and looking at the building to the mirror, which is the iPhone. What we got in measurement was 64 centimeters. And now we're going to measure the distance between the mirror and the building or wall. So we got that the distance from the mirror to the building was 484 centimeters. Okay, so now I'm going to draw, and keep in mind my drawings are not very good and this is not drawn to scale. So there was a mirror we were looking at, and remember that we need to measure from the eyes in the mirror method and not from the top of your head. And here is a building we were looking at. So obviously, again, it's not drawn up to scale. Some decoration there. There we go. And now we needed to find the distance from my eyes to my feet. And that distance we said was 167 centimeters. And then we needed to find the distance between me and the mirror. And that distance was 64 centimeters. Okay, so now we have one triangle done, as you can see there. I'm going to explain it further, but so the ratio right now of the first triangle is 167 centimeters to 64 centimeters. And now we're drawing the second triangle, and we know these two triangles are similar because when I was looking to the mirror, I was seeing directly to the top of the building. So this means that they have the same ratio. So we measured the distance between the mirror and the building, and it was 484 centimeters, and we wanted to find the height of the building. So this is what my equation is going to look like. And as you can see there, I'm drawing some lines because that's the triangles I was talking about. There's two triangles, so I'm going to draw them out for you. One looks like this, and it is the one connected to the building, and one looks like this, and it's from me to the mirror. Okay, so now that we got an equation to work with, let's make it into a two-step equation. So we got 167 divided by 64, remember these are all centimeters, equals x over 484. Now you crisscross and you do 64 times x, which is 64x, and then this is equal to 167 times 484, which is 80,828. And now we want to leave the x alone, so we divide by 64, and what you do to one side you do to the other. So 8,828 divided by 64, and that gives us a grand total of 1263. Obviously, this is round to the nearest centimeter. And now we're going to do the shadow method. So basically how the shadow method works is that you measure an object and then you measure the shadow that it portrays, and then the object you want to find the height of, you find the measurement of the shadow. So here we're finding my height and it's 179 centimeters, and keep in mind this is now your full body measurements and not until your eyes. And then we want to find the shadow, which is what we're doing here, and the shadow was 108 centimeters. So now all that's left to do is find the measurement of the shadow of the building. So here we have a measuring tape and we're measuring it all the way until the point where the shadow stops, and it was equivalent to 764 centimeters. So let's go back to the drawing board, and again I'm sketching me here. And keep in mind that if you want to do both of these two methods, you have to do it with the same person or object, otherwise it would not work. And also you have to do it in the same time of day. So we were measuring my height, and my height was 179 centimeters, and this was the building, and we needed to find the shadow. But first let me add some decorations. And now we needed to measure the shadows, and now since it was in the same time of day, both my shadow and the shadow's building would be similar. So my shadow was equivalent to 108 centimeters, and now we draw our ratio with it, which is 179 centimeters over 108 centimeters. And now we just needed to find the height of the building. So to do that, we need to find the shadow. So we measured the shadow, and so as I said before, my shadow and the shadow's building are similar, and the shadow's building was 764 centimeters. So now we draw x over 764 centimeters, and both shadows need to be next to each other, or at least the way I do it, because this shows that they are equal to each other. So now that we have the equation, I just wanted to show you that there are triangles made. If you haven't noticed yet, the shaded region is one triangle, and now the other shaded region is the other, and they are both similar, but one is bigger than the other. So now we just need to solve the equation. And the equation was 179 over 108 equals x over 764 centimeters. Keep in mind these are all centimeters, but I'm just putting it once because I don't want to get too repetitive. So then we crisscross, and it's 100x equals 179 times 764. And this is equal to 136,756. So now we just plug that in, and it's 108x equal to 136,756. We divide 180 by x, and what we do to one side we do to the other, and we get x equals 1,266. And just to reflect, I wanted to let you know that the overall reason we did this was to find the height of the building. We did this with two methods, and the ideal thing was to have the same height. There might be some errors measuring, but we got pretty close with both our answers. So the shadow method answer was 1,266 centimeters, and the mirror method was 1,263 centimeters. So this was just a 3 centimeter range from one to the other. So why was there a 3 centimeter difference? Well, there could be many errors, but previously we had a measuring tape that wasn't the best measuring tape for this job. As you can see there, he had to put his finger, but then we found another measuring tape just for this shadow of the building, and we measured it. The other reason why there could be a 3 centimeter range was because I moved slightly when my shadow was measured, but overall the two experiments went good and we are happy with the results. So that's all for today and thanks for watching.